Hello everybody. Well, first I want to tell you that I'm very happy to be in this beautiful place. Thank you for the organization team. I'm more than happy because I was part of the organization last year, so I know the pain. So it's very nice to be there without any preparation work. I want also to remind maybe quickly all the Schneider-Electric team who is there. So of course we have the talent team, part of Schneider, so with Manuel Parra and Joaquin Lauri. We also have the local Netherlands team who is present today. We have Barry Cressy from UK that maybe some of you heard last year presented something about telemetry. Now Barry is in charge of the water business for Schneider-Electric in UK. We also have Véronique Boutin, who is in the R&D team, innovation, working on energy efficiency. And we also have Cédric Latessa, who is not Schneider-Electric, but Aster Capital, which is a venture where Schneider-Electric is participating. Okay, so the subject I'm going to talk about is typically the kind of subject maybe where the Swan could bring value. We had a discussion this morning about what is the Swan, or even more, what is it made for. So this is a subject where we are not going to show something that has been made. We are going to test with you a possible collaboration, a subject where we want to go further, maybe to learn also from some of you what's your understanding of the need, interest, and how we can work together. So Laurie Reynolds this morning explained that there was a parallel between the Swan and the smart grid. So just after lunch now I have the challenge to make these two parallels meet together, which is quite unusual. So I'll try to achieve that. Because the idea there is to combine these two ideas and to see how the water utilities can take advantage of these smart grid values and become prosumers. So first a quick reminder about the smart grid and demand response. In one slide I'll try to explain you what it is about and how we can consider the position of water utilities as prosumers, which means being both consumers of electricity but also electricity producers. Now we're going to see what are the complementary services to classical Swan approach, I would say, that are necessary to achieve this. And then, of course, we'll finish by the call for collaboration that we can discuss also during the panel. Well, first the definition. So I don't know if we have an official definition of the European Union for smart water networks, but apparently there is one for smart grid. And I think we can apply it quite well to the Swan, because it explains that it's a common interest, I would say, between the people consuming energy and producing energy, and the one that do both. So it's probably something we can inspire for the smart water network. So we're going to talk about demand response. This is highly linked also to the smart grid and the fact that we have more and more renewables in the smart grid, in the electrical grid, sometimes inside the consumer grid, like in water, for instance, where we find a lot of solar energy or wind power. It's all about flexible distribution, and here we're going to focus, of course, on this piece of the puzzle, which is the position of the water utility. So just a reminder on the smart grid. So there is an evolution from centralized generation to distribution and transmission, distribution, and then the users, the consumers. Many changes there. First, on the generation side, the electrical utilities, they now use a lot of renewable energies, which changes the way they have to balance consumption and production. So it's generation. So that's key to understand this. The big difference is that it's very easy to store water, which is not the case for electricity. So in electricity, there is this challenge, constant challenge with very short, maybe also time frames to balance all the time demand and generation. So as I said, these renewables now are located also on the consumer side. Another evolution is that's something we addressed last year about energy efficiency. So more and more active energy efficiency, and I would say that the active energy efficiency is modifying my own process to actively reduce my energy consumption. So that's a first step. We're going to see there that we're going to go further. For some of the consumers, we have also the growing market of electrical vehicles that will change also greatly the way energy is managed. Especially if this is successful, we're going to see a lot of changes there in the need to manage the electrical grid. And of course, exactly like in the Swan, we have a challenge of communication and management of this grid. So we see there a picture where water utility play a key role, I think for two reasons. The first one has been mentioned this morning, is that water is one of the key or the larger consumers. And the second one is this capability to store, which is probably very specific to water. So let's move a little bit to the business side of it, because there is money involved there. So I think there are two key parts to understand there. One is what we call commercial aggregation, or the fact to put on the market bricks of energy. So here, a key, I would say, a key input in a country is what is the minimum brick of energy that I can negotiate, sell or buy on the energy market, and that can vary a lot. In UK, for instance, it's 3 times less than in France. So that's an important input. Is in your country, what's the size of this minimum brick? For water, we have a challenge. The electrical consumption is spread in a water network, so it's very difficult to reach this minimum brick of energy in a single location, in a single consumption point, as opposed maybe to some intensive industrial facilities. So there is another step that you can see there in the middle on the right, which we call technical aggregation. So technical aggregation is inside my own water utility. How can I already aggregate my energy bricks? So the idea is to say, let's say I receive from the electrical utility an order that within 20 minutes I must make available a certain amount of energy. How can I do that inside my company, inside my water utility? So we can mention two possibilities. One is in treatment plants. In treatment plants, you can have some backup generators. So instead of using these backup generators to back up power when there is a lack of power, you can decide to start them just to reduce your consumption or make energy available to the electrical grid when you're requested to. So that's a possibility, but that's not always permitted. In some countries, like in US or in most part of France, it's forbidden for, I would say, sustainability reasons, which is not the case in UK where it's possible. So that's one possibility in treatment plants. Another possibility in networks, of course, we know that the drinking water network is the consuming one. So the idea there is to say, how can I modify my network behavior, my water network management, so that I can stop enough pumps at the same time to reduce my consumption and then make some energy available on the electrical grid. So, of course, the main job of water utility is to service the consumers, so that must be done without affecting the pressure, the water quality, because maybe you store too much the water or whatever. So, of course, this is where it's highly linked to the smart water network management, because if you have a smart water network management, then that makes what I've just said possible, because you know how to manage it. So we see that this is probably the place where the two domains are crossing, where the two parallels are crossing in this possibility to manage the water network in order to achieve this technical aggregation. So we see there that there are two, I would say, category of services. One is outside the water utility. How do I make money with these energy bricks? So how do I put that on the market? So there are companies specialized in that. So in Schneider we have a company called the Energy Pool, active today in France, starting in UK. So this is the kind of company able to work with different industries and help them or negotiate on their behalf their energy bricks on the energy market. That's one category of service. The other category of service is more inside the water utility, how we can work together to manage the network or start the generators, as I mentioned, to make this energy available on request, when requested by the electrical authorities. So you see there are two groups of services. So of course the first group of service is not really linked to Swan. It's a specific business and not really linked to the day-to-day management of the network, or the water network. Whereas the second category of services is really closely linked to the optimization of the process and of the network management. So that's really where Swan and Smart Grid, I think, closely meet together. And that's also where it's specific to water. So where the category of services on the left, on the commercial aggregation, it's the same kind of mechanism whatever the industry is. Whereas on the right side, it's really specific to water, and if we are not proactive in this field, probably nothing will happen. And of course, what I didn't mention is that this second category of services inside the water utility is of course linked to energy efficiency. I mean, it's according to definitions, we can consider it's part of energy efficiency. For other specialists, energy efficiency is more on the saving of energy, whereas in this case we talk about generating energy. But anyway, it's the same kind of energy management mechanism and services. Okay, so just here trying to list the services. So of course they're really linked together. So it means that both for energy management and for water network management, we need to manage historical data, to manage, I would say, in real time the network, and to work on the forecast. So we come back to many discussions we had around the Swan on these subjects. The different scenarios to save energy, there's load shifting, which consists in delaying the consumption of electricity, a load shaving, which is more avoiding peaks, and that's more energy efficiency side. Load shedding, it's just suppressing a load by stopping a pump, for instance. And of course that has to be done, as I said, by keeping the process efficient on the water side, so probably some predefined scenarios there are requested. So start, stop, pump and generators, that's the basic idea. Control the CO2 emissions, that's more on the energy efficiency side. Manage locally produced energies, because in the same manner, I would say that the electrical utility balances the demand and the generation. That can be done also locally by the consumer, in this case the water utility, who has also maybe to manage these different generation. And of course, keep the quality of the water that is delivered to the consumers in terms of age of the water, pressure, and so on. So we see here really a sort of imbrication, I would say, of the water and the energy management. Okay, so just here illustrating the kind of combined systems that are required, combining energy management here on the top of the screen and smart water network management. So that's really what is required in this case, is a combined management of the two networks. Okay, so it's an extension. So energy efficiency is quite widespread now. Everybody is putting in place measures to reduce the consumption. So there it's an enlargement of this approach. And we're really ready to collaborate and learn also from you on this subject. So I will be happy with our Schneider team to hear from you on this subject during the panel or afterwards. I'm done.